In this session, we're going to talk about Newton's laws of motion. Okay, so to explain this concept, we're going to use the tutorial sheet on Newton's laws of motion. Okay, so you do well that as we are solving these questions, question 1, 2, 3, and 4, you're also pausing the video and you're practicing, because physics is about practice. Okay, so without wasting much of the time, let's start with the first question. Now, the first question reads, a 45 kg woman stands on a spring scale inside an elevator. The scale reads the force with which it pushes upward on the woman. What does the scale read when the elevator is accelerating? A, upward at 3.65 meters per square second. B, downward at 3.65 meters per square second. Okay, so this is a very interesting question. So what do we have? So allow me to write my data here. So the data that we have, we've been given the mass. We're saying a 45 kg woman. Okay, so the mass is equals to 45 kg. Okay, on the elevator, it pushes upward. On the, what does the scale read when the elevator is accelerating? If we're starting the first question, acceleration we've been given to be 3.65 meters per square second. Okay, then what other thing have we been given? We're talking about she's accelerating upward or downward, and there's this aspect of an elevator, so it means she'll be under the influence of gravity, right? So let's say the acceleration due to gravity is 9.8 meters per square second. Okay, so this is the data that we have. So what are we trying to find? What does the scale read when the elevator is accelerating? What does the scale read? So it means we're measuring the what? The weight. Okay, so if this is the information that we have, let's solve A now. So let's assume this is our woman, this is the elevator. Okay, this elevator is taking this woman upward. Allow me to represent, I'll not really draw the woman, but let's just assume that this is a woman. Okay, now what forces are going to be acting on this woman? That's the first question that you should understand and ask when you're solving Newton's laws of motion questions. Okay, so there will be a weight force. She will have weight, right? Okay, that is going down. I'll abbreviate it as W. Okay, this woman also, there will be also some net normal force going up. Okay, which I'll abbreviate as N. Then at the same time, we're saying she's moving upward. There's a force that is pulling her upward. Okay, let's call this force as F. Okay, F. So these are the forces that are acting on this woman. Now the forces that are going up, let's assume that going up is positive, coming down it is negative. Okay, so now what do we have? How are we going to find what we have? So we have to first find all the forces that are acting on this woman. Okay, so we have our weight in this case, so it will be negative because it's on the negative side, plus our normal force is going up. So we have two forces that are going up, the normal force and the force that is taking her upward. Okay, all these forces, they should add up to 0. Okay, so now what is our weight force? You know that weight is just equals to mg, right? But in this case, let's make weight the subject of the formula, because that's what we're finding. If I take the weight to the other side, it becomes a positive, right? That's what I'm going to do. Okay, so I'm going to have weight is equals to F plus N. Okay, now what do we now have? You know that the force that is acting on this woman, okay, so it will be the force that will be like due to gravity. Okay, so we have mass times acceleration, which is ma, that's our find force, right? Plus the normal force. Now the normal force in this case, it will be like the weight force. It's just that it will be in the opposite direction, and the way we measure weight is what? mg. So what are we now going to have? The mass for this woman, we're saying it's 45 multiplied by the acceleration. The acceleration that we've been given is 3.65. So I'm going to write that 3.65. Okay, I'm not going to write the units. Then the mass is still 4.5, doesn't change. This is multiplying by, now the g is the acceleration due to gravity because she's going up. Okay, so that would be, because we've taken up to be positive, our acceleration due to gravity will also be a positive. And when we solve this, it's just giving me on my end 605.25 Newton. Okay, so this would be the weight as she is going upward, as she is accelerating upwards. So that's how we solve the first question. Okay, so let's solve the second question. So we're finding B. So it's the same scenario, but what is happening now? Okay, let's assume again this is our elevator, and this is the woman. So the question still stands, what forces are acting on this woman? Okay, but now B, we're saying she's going downward at that acceleration. She's accelerating downward at that acceleration. So what do we have? You know that she will have a normal force. Okay, the normal force will always be there. Okay, so it's going up, normal force, which we've abbreviated as N. Then she'll have the weight force. Okay, W. Then there'll be also a force that is pulling her down, right, from this elevator, which we are saying it is a force. Okay, or MA. Now what are we now going to have? These are the forces that we have. So likewise, if we choose going up to be positive, coming down to be negative, so what are the forces that are acting on this woman? So we've got N, we've got minus W, we've got minus F. All these forces, they should give us a 0. So what do we now have? If we are going to make weight the subject of the formula, okay, so I'm going to just take this negative W to the other side, and it gives us a positive W. So therefore W will be equals to N minus F. Okay, then what is our N? N, we said, is our normal force. Normal force just the same as mg, right, minus our force. In this case it is mass times the acceleration. Okay, now the mass we've been given is 45 multiplied by the acceleration due to gravity, which is 9.8, minus, when you come to the mass, still the same, 45. The acceleration due to gravity, we're saying it is 3.65, the one they've given us. Then we solve. When we solve, my weight, I'm finding 276.75 newtons. So this will be the weight when she's going downward. That's what the scale is going to read. So let's solve the second question. So for the second question, we are told when a force of 450 newtons pushes on a 20 kg box as shown, the acceleration of the box up the incline is 0.7 meters per square second. Find the coefficient of sliding friction between the box and the incline. Okay, this is an interesting question. Okay, so okay, maybe to explain it better, probably the diagram there is a bit small. What are we going to do? Allow me to draw a bigger one so that we explain some concepts that you're supposed to know. So let's say this is the incline. Okay, then this is our box. Okay, so allow me to extend it like that. So what are the forces that are going to be acting on this body or in this on this box? So we've been told there is a force in this direction. Okay, now what forces does this body exert just by itself? What forces does it exert? So you know that if this is the center of this box, it is going to have a normal force going up, right? So let me indicate the normal force. So it's going to have the normal force going up like that in a straightward manner. Then it's also going to have a weight that is going to be going in this direction, pulling it downward like that. Okay, so these are the forces that are going to be acting on this object. Then the other thing is that this object, this box, because you're pushing it in this direction, it's going in this direction. There's going to be another friction that is going to be opposing, another force that is going to be opposing this motion. It's going to be going in the opposite direction. Okay, so let's put what we are talking about. So you're pushing it at this, and what are we going to have? So if it is like that, we have to resolve our vectors into what? Into components. You remember that. So now, if these are the forces, force is a vector. So let's resolve our forces and our acting forces on this object into its components. Okay, so for the normal force, we know if you resolve it into its component, you have this one and the other one like that. Then for the weight force, if you are going to resolve into components, it's going to be this one and this one. Okay, then the other one, because it is at an angle, so what are you going to have? It's going to be this one and this one like that, straight. So these are the forces that are acting now on this object. So let me just indicate them. So we said you are pushing this box at 450 newtons. Okay, so it means this one, because it's in the f direction, is in the x direction, we're going to have Fn cos. Now we're going to have an angle. If this is 90, so it means this one will be 45 and the other one will be 45, right? So the angle that will be made as you are pushing, this one will be 45. Okay, that one will be 45. So because this one is 45, the other one this side also will be 45. Okay, then so this is Fn cos 45. This other one will be Fn sin 45. Okay, for the normal force, this is a normal force going up. I'm not going to indicate it. Then the weight force, which is same as mg, right? Because weight force is the same as mg, therefore what will be our components? So this one will be mg cos 45. The other one will be what? Mg sin 45. Okay, so those are the angles that we have. So this is 90 degrees, so this one will be 45 and the other one 45. That's why I've used 45 degrees. Okay, now that we've got this, what other thing do we have? Okay, so this can also be 45. If we say this, if we drew a line like here, and this has been cut in the middle in terms of an incline, that will also be 45. So I think we have everything that we need on this diagram. Now what data have we been given? So allow me to write my data here. So the data, let's look at the mass. What is the mass that we've been given? We're saying a 20 kg. So I'm going to write 20 kg. That is the mass. Then the force, it was pushed at a force of 450 Newton. Then the acceleration, it was accelerating at what force? So acceleration, we are saying an acceleration of at an incline of 0.7. Okay, so 0.7, so we have an acceleration of 0.7. so allow me to write 0.7 meters per square second. That is the acceleration. Then we are asked to find the coefficient of sliding friction. Okay, so let me just put it here, Fk. Okay, so that is the coefficient of kinetic friction, because as it is moving in this direction, there will be a friction force that is pulling it in the opposite direction. So now we're finding the coefficient of sliding friction. So in this case, we're just going to have our mu like that. So we don't know about that one. So this is the data that we have as for now. So we're going to use this data to find what we have. So what forces are acting? So if we say so which forces are we going to get? You know that the friction force itself is acting in the in the x direction. So because it's in the x direction, we're just getting the forces in the x direction. Okay, we'll not get all the forces that are in the y direction. Okay, so summation of the forces in the x direction, summation of the forces in the x will be equals to, you know, ma, right? Your mass times your acceleration. Okay, that will give us the total force. Now when we summate what we have, okay, if we take coming this side as negative, going the other side as, let's say, positive. So if we've got if we choose that way, what are we going to have? So able to see that we've got Fn cos 45 is going in that direction to be positive. We've got our Fk, or let me say our friction force. Our friction force is going in the opposite to have a negative sign. Then what other force is also acting in the y direction? You're able to see that there is in the x direction, there is also this other force that is acting in this direction. Okay, so these are the forces that we're going to get, and we solve. So we are saying we have Fn cos 45, then we have a friction force which is in the opposite direction, F, minus this one is also going in this direction. Okay, so like that, this one is also going in that direction, so it will also be negative. So allow me to just put it like that. So minus mg sine 45 is equals to our mass times acceleration in the summation of the ma is the summation of all the forces in the x direction. Okay, which is the total force. So now how are we going to now find our answers? Okay, since our main interest is finding our friction force, so if I'm going to take the friction force to the other side, okay, if I'm going to take the friction force to the other side, if I take it this side, it becomes a positive, and if I take the ma to the other side, it becomes negative. So what am I going to have? Therefore my equation will be friction force in this case would be equals to I'm going to have Fn cos 45 minus mg sin 45 minus ma. Okay, so this is what I have. Allow me to just rub what is on top. Okay, so now our friction force, how do we find the friction force? So now you know that the friction force is just the coefficient of kinetic friction multiplied by the force, like that. Okay, is equals to Fn cos 45 minus mg sin 45 minus ma. Then because we're finding the coefficient of kinetic friction, we're not finding the whole friction, so it means we're going to divide by Fn on both sides, right? So if I divide Fn, even the other side Fn, so Fn and Fn the other side, they're going to cancel, right? Therefore my u or my mu, what is it going to be? I'm going to have Fn cos 45 minus mg sin 45 minus ma. Okay, now that we've got this, what do we now do? So our job now is just to replace. So we're saying this side is divided by Fn, so mu is equals to, now what is Fn or the force in that direction? Okay, so that's another question that you should ask yourself. So what is the force in the other direction? So force Fn, what is our Fn? So we're saying Fn because it's in this direction, it's the force, so it will be ma, right? But now in terms of with it will be like mg, okay, because it's under the influence of gravity. So our mass, it is 20, you know that. Our acceleration due to gravity is 9.8. Then we are saying cos 45 minus mg sin 45. Now mg, our mass, it is what? It is 220 multiplied by 9.8. The sin 45 minus our ma, our mass is 220 multiplied now by our acceleration. Okay, so what is our acceleration? We've been given an acceleration of 0.7, so we're going to put it 0.7 divided by, okay, the kinetic friction, the Fn. Okay, now the Fn in this case, it will be the weight force, okay, because it's going in that direction. So the weight force, you know, we've got two, we've got this one and this one, that is the Fn down. So what do we have? So we're going to have mg cos 45 plus again mg sin 45. Now let me just replace downward so that I just solve everything together. Now my mg, the mass down, is 20, the acceleration is 9.8 multiplied by cos 45 plus my mass in this case, or mg in this case. Now look at the direction of this one. Okay, so the direction of this one, mg, is just the same as your 450. Okay, so this will have 450 sine 45. Okay, now when you have that, all we just need to do is just to add up and subtract and all those everything that we have. Therefore our u will just be equals to, on top, when I just do everything that is on top, what am I getting? I'm getting 165.605 divided by, when I do what is down, 29.8 cos 45 plus 450 sine 45. I'm getting 456.791, and when we divide that, 165.605 divided by 456.791, I'm getting 0.362. so this would be our coefficient of kinetic friction. So that's how we're going to solve the second question. Let's solve another question. Now this question is saying the rear side of a truck is open and a box of mass 20 kg is placed on the truck 4 meters away from the open end. If the truck starts from rest with an acceleration of 2 meters per second on a straight road, find the distance the truck will travel when the box will fall off from the rear. The rear is just the behind. Okay, they've given us the the coefficient of kinetic friction to be 0.15. okay, so how are we going to solve this one? Okay, so what data have we been given? So let's account for the data that we've been given. So the mass, it is 20 kg. Okay, the distance we're saying 4 meters away. Okay, 4 meters away, so the distance d is 4 meters. Acceleration, it starts from rest with an acceleration of 2 meters per square seconds. Okay, so acceleration is equals to 2 meters per square seconds. Okay, then we've also been given the coefficient of kinetic friction, which is 0.15. okay, 0.15. What other thing have we been given? Okay, let's just also put the acceleration due to gravity to be 9.8 meters per square seconds. Okay, because there will be some weight that this box is going to be carrying. Okay, so how are we going to solve this one? Let's look at the forces that are acting on this object. Always, that's the first thing that we are. Okay, let's assume this is the truck. Okay, the rear side in this box, let's say it is here. And it's about to fall off. Let's say the distance from here, when it just crosses that distance, it falls off. Okay, so now that we've got this, what forces are going to be acting on this object? Okay, so because a truck is open and it's placed away from the, okay, if it starts from rest and acceleration of on a straight road, find the distance. So there'll be a force that is pulling this object in this direction. Because the car is going in this direction, there'll be a force that will be pulling it in the other direction, right? But in as much as that force is pulling it in this direction, we'll have a friction force that is pulling the object in that direction. So this is a friction force and this is a force. Then we have an mg here and you have a normal force. Okay, then we have a distance that is going to move. We're saying it is 4 meters. So what do we have? Let's find first the force that is going to act on this object. You know that force is going to be mass times acceleration. The mass, it is 20, multiplied by the acceleration, which is a 2. Okay, our acceleration is 2 meters per square second. So when we multiply, we're just finding the force to be 40 newtons. Okay, we found the force to be 40 newtons. But now, what forces are going to be acting, you know, in the x direction? Because this object is going to be moving in the x direction. Okay, so what forces are going to be acting on it? Okay, so you're able to see that you have the force and the friction force itself. So what are you going to have? So we're saying friction, let's take this side to be positive. Okay, let's say as you are going this side, let's say this is positive. If you're going on the other side, let's say you're going this side is positive, but when you're coming the other side, it's negative. So the friction side is going this side, so let me say it is negative, then this other one is positive. Okay, so what are we going to have? We have force, in this case the force that is acting on this object, minus the friction force, is equals to you know, let me say MA, or the summation of all the forces in the x direction. Okay, so now let's make acceleration to be the subject of the formula. So what are we going to have? It means I'm going to divide by mass on both sides. So acceleration is equals to force minus the friction force, you know, that is just found by nu Fn, okay, divided by the mass. Now what are we now going to have? Our force, we found that is 40 newtons, minus our coefficient of kinetic friction we've been given is 0.15, okay, here, multiplied by the Fn. Okay, now the Fn in this case, it is let me say the mg, okay, or like something like the normal force. So mg in this case, the mass, it is just going to be 20, multiplied by the acceleration due to gravity, which is 9.8, divided by the mass on the other end is just a 20. Okay, then we solve to find the acceleration. Now when I solve that, what am I getting? 40 minus 0.515 multiplied by 20 multiplied by 9.8. Don't forget to put them in brackets. Answer divided by 20. Okay, so the acceleration that I'm finding is 0.53 meters per square second. Okay, so allow me to keep my acceleration there. Okay, because our interest is not to find we found the acceleration because we're trying to find the distance, but we can't find the distance based on what we have. Okay, so what do we now do? So for this distance now, for this distance that we have, for this distance that we have 4 meters, what are we going to have? So the distance in this case, S is equals to, we can use that formula, S is equals to UT plus half AT squared. Now my interest here is to find the time it's going to take for this, you know, object to fall off. Okay, so what am I going to find as my time? We've been given a distance that is going to move. We are saying it is 4 meters. So 4 meters is equals to, since this object started from rest, they are saying it started away from up, and the track starts from rest with an acceleration of that. So if, because our u will be 0, right, multiplied by the t, which will be this whole expression will give us 0, half acceleration. Now the acceleration that we've just found, this one, okay, is going to accelerate at 0.53 meters per square Oh yeah, that would be the acceleration multiplied by the time that we're trying to find. Okay, so this side of 4 is equals to what am I going to have on the other side? This will give us a 0. I'm not going to write it. This one will give us a 0. I'm not going to write it. Then half of 0.53 just gives me 0.265. Then there's t squared. So for me to remain with my t squared, I'm going to divide by 0.265, 0.265 even on the other side. So therefore my t squared will be equals to 4 divided by 0.265. I'm getting 15.09434. For me to remain with my t, I'm going to square root on both sides. So t is equals to the square root of what I'm just from finding, 3.885 seconds. So this is the time that this object is going to move as it is, dropping off from that. Now that we found the time and we have everything, now we can find the distance. Okay, find the distance the truck will travel when the box will fall off from the rear view. Let's now find the distance this truck now is going to move itself. Okay, this is the distance for the box. What about the truck itself? So we're going to use the same formula. S is equals to ut plus half at squared. Okay, our ut we're saying is starting from x0, or starting from this truck started it starts from rest. If the truck starts from rest, so the initial acceleration, the initial velocity is 0. So I'm just going to write half multiplied by the acceleration. The acceleration we are saying it was this truck itself, it was moving at 2 meters per second. So I'm going to write my 2. Okay, multiplied by the time that we found. Okay, 3.885 squared. Okay, so when I solve that, half of 2 is just 1 multiplied by, so I'm just getting 3.885 squared. That just gives me 15.1 meters. So this is how you find the distance that this truck is going to move. Okay, let's solve the last question. So now we are saying two blocks with masses m1 is equals to 3.2 kg and m2 is equals to 4.1 kg are touching each other on a frictionless surface. Now that is very important information. Okay, or in a frictionless table, if the forces, or if the force F is equal to 6.8, what is the acceleration of the two blocks? B, with what force does M1 push? With what force does M1 push against M2? Okay, repeat A and B if F is the reverse direction and pushes on M rather than on M1. Okay, so first and foremost, always write your data so that you know what you have to find what you don't have. So allow me to write my data here. So we are saying there are two boxes. One, we have got M1 and M2. Okay, in terms of the masses, M1 we are saying it is 3.2 kg. So I'm going to write it 3.2 kg. M2 is 4.1 kg. Then what other thing have we? If the force F is equal to that, okay, we've also been given a force, okay, the force that is acting on this object to be 6.8 Newton. Okay, so what are we supposed to find? A, we're told to find what is the acceleration of the two blocks. That is A. Okay, so what would be the acceleration? So in this case we've been given a force. Force is equals to mass times acceleration. We're using what we have. We've been given a force, so we can find the acceleration from that. So let's make acceleration the subject of the formula. You know that I'm supposed just to divide by m on both sides. Therefore, my acceleration will be equals to force times the mass. Now, the mass that we're talking about, because these two objects are moving together on a frictionless surface, so the mass will be the mass for both, or a combination of m1 and m2. So allow me to write it m1 plus m2 to represent the mass down. Okay, therefore what am I now going to have? I'm going to have my acceleration is equal to the force we've been given is 6.8 divided the mass for m1, or m1 is 3.2 plus m2 4.1. okay, so acceleration will be equals to 6.8 divided by 3.2 plus 4.1, that is it 7.3. okay, then 6.8 divided by 7.3, okay, so it's giving me 0.931 meters per square seconds. So that is the acceleration for the first answer. So allow me to keep the acceleration and allow me to rub everything. Probably we might need it as we are solving the other questions. So let's solve B. B, with what force does m1 push against m2? okay, with what force is m1, with what force does m1 push against m2? okay, so you know that force is still equals to mass times acceleration. So with what force? So the mass, which one are we talking about? With what force does m1 push against m2? So you know that the force for the mass for m2 is 4.1. so the mass is 4.1, the acceleration is 0.931. okay, so this is what we are going to use. Now we are using this because the same force that m1 is going to push on m2, that's the same force that m2 is going to push on m1. That's why we've gotten the mass for m2, because it will also exert a force that is opposite but equal, okay, according to Newton's law. So when I multiply that, the force that I'm just finding as B, it is what am I going to have? Okay, the force, it is 3.81 Newton. That will be my answer. Then C, repeat A and B if force is in the reverse direction and pushes on M rather than on M1. okay, pushes on M2 rather than on M2. So what are we going to do? Repeat A and B. Repeat A and B if F is in the reverse direction and pushes on M rather than on M1. Okay, so what are we trying to find? We've for box M1 to move at this acceleration, what is the acceleration of M2 or M1? Because we've only found for this is for M2 3.81. Let's find for M1 the force. So the force that M1 is exerting, so force will be equals to mass times acceleration. The mass for M1 is 3.2. This is multiplied by the acceleration, which is 0.93, because they are moving at the same acceleration. They are accelerating at the same time on a frictionless surface. So when I'm solving this on 3.2, 0.931, it's giving me 2.0 979 Newton. Okay, so what do we have? So we're having this one. Now M2 is greater than M1. Now I told to repeat A and B if F is in the reverse direction. But now it's not in the reverse direction, so we're not going to do anything to what we found on A and what we found on B. Why? Because B actually will be pushing backward A. Why is it pushing backward? Look at B. Look at the mass for B. The mass for B, it is 4.1. Okay, so then the mass for A, it is 3.2. The mass for B, it is just greater. Therefore the force that is going to be pushing against A to be greater. Okay, now they're telling us to reverse if we don't find it so. Okay, we are reversing because it won't make sense to say a bigger object, the force, a smaller object is pulling a lot of force, a force of let me say small force of one object is able to counteract and oppose a larger force, which is not, it's against Newton's laws of motion. There's nothing like that. Okay, so that's how you are going to solve this question. So see you in the next session. We're going to be talking about other questions.